So class D is used for multicast purposes and it is used for router to communicate in between themselves. So this will be used by the routing protocols as such like RIP version 1 and version 2, OSPF, EIGRP, so on and so forth. There are some routing protocols which we'll discuss in the later session. But for now, you are aware that what are the classes of IP addresses, from which IP to which IP it ranges, right? And how do we annotate each class of IP address? So today we will begin with the easiest class of IP address under subnetting, that is type C, right? So why are we telling that this is the easiest uh, class of IP address for subnetting, to learn subnetting in fact? The reason being, it is ranging from 192.168.x.x, right? So any IP address with this particular IP, if it has 192 and 168 in the initial two decimals, that's a type C IP address, right? And its subnet mask is annotated within the network as 255.255.255.0. So what does this indicate? This indicates that this is occupied by the network. This decimal also is occupied by the network. This decimal is occupied by the network, right? What is remaining? So only one host bit is remaining for us to play around to create IP addresses, right? So we know that each decimal within this octet consists of how many bits? It consists of 8 bits each, right? So each decimal is consisting of 8 bits here, 8 bits here, 8 bits here, 8 bits here, right? So all in all, for IPv4 type C address, we have the initial 3 octets, that is overall 24 bits, is already occupied by the network address, right? So you only have 8 host bits to create the host network among this particular network. So you have only 8 bits in order to create subnets, right? So now, how do we actually do subnetting? So there are two types of questions in subnetting, first type and the second type. So in any interview or in any place, you will only be asked the question on these two types of questioning for subnetting, right? So one way could be that they will give you an IP 192.168.10.0. I'm just taking a random IP address here, right? And I ask you, for this IP address, give me 8 subnets. Give me 8 subnets. Create 8 subnets from this IP address and you give it to me. So that is what I am asking you to create. So this is the number one type of question, right? Not only question, this also is valid in your day-to-day networking infra also, right? So that's the number one thing what you might be having challenges upon. The next thing is they will give you an IP address 192.168.10.0 and they will give you a subnet mask, right? Let us assume in our current, for example, I am taking 27, right? So all of you are aware that how many bits are occupied by the class C IP address? 24, right? So by default, IP address which is ranging in class C has how many? 24 network bits reserved for itself. So you cannot touch them. You cannot use them, right? So for this particular question, what the questionnaire or whoever is asking you this question, or maybe tomorrow if you have some sort of a job you have to do related to subnetting within your infra, if you have such kind of an IP address, what does this indicate is that this indicates that since it's a type C IP address, 24 are already for the network portion, and to in order to create subnets, whoever has created this IP address, they have borrowed 3 host bits. They have borrowed 3 host bits. So what I'm trying to tell over here is, for this particular thing, I told you that the initial one is occupied by the network, that is 8 bits are already occupied. The other one is also occupied by the network already by default, that 8 bit is occupied. Then another one is network bit, this is also occupied. But the only bit which is remaining, that is 1, 2, 3, and 0, 0, 0, 0, 0. So why I am writing 0 is for our understanding, right? So what I'm trying to convey over here is that we are borrowing these 3 bits towards the network side, right, in order to create a subnet. So once you borrow these 3 network bits, this 24 becomes 27. So you borrowed 3 bits from the host section in order to create a subnet. So that is what this question means, right? And the calculation for how many, and in general, you will be asked only this question. That is, first question would be, what is the, no, yeah. So the first question would be, what is the network ID, right? The second question would be, what is the end IP address, right? Third question would be, what is the broadcast IP? Done, right? In this scenario, your question should be, what is the network IP? What is the, how many usable IP hosts per network, right? And what is the broadcast IP per network? They might ask you per network, or they might, or give you an network ID and ask the broadcast, right? So that's how it actually works. So these questions are not only for CCNA, CCNP examination perspective. This is something which you will be using in day-to-day life when you join as a network engineer, right? You might be into networking, core networking job. This is what you will have to do for sure in your day-to-day life. If you're into security perspective, you may need not do this sort of a thing. But learning is important because each and everything would require you to understand how subnets have been created and how you have to actually handle them, how you will be routing it. So in order to identify an issue also, you must have an idea about this. So this is very important, right? So now what we'll do is we'll go step by step. What we'll do is we will start with the first, a little bit difficult, a little bit formula related calculation for creating 8 subnets from this, right? And then we will see how we actually create, or you identify how many, how you answer this particular question when a questionnaire is given like this, right? Mostly you will be asked this particular question in an interview if they ask. The reason being, this is the simplest way an interviewer can test you whether you know subnets, whether you know networking or not, right? So now let's begin with this one. So our question is, I want everybody to take notes. So this is really important. You will not be able to understand the concept without taking notes, without understanding things. So not a problem if we do not cover today's subnetting in today's session. We'll continue tomorrow. But I need everybody to understand how subnets are actually created and what all formulas goes into it and how to actually identify things. Okay. So when a question is given to you, first write that question down. So our question is 192.168.10.0, and they are asking us, please create 8 subnets from this particular IP address. So this is what they will give you, nothing else. So what tools you have got? So the number one formula you have got is 2 to the power of network bits borrowed. 2 to the power of network bits borrowed from the host bits is equals to the number of networks. Please make a note of it. Number of networks. Right. Second thing, how many hosts? How many hosts per network? How many hosts per network? The number of host bits remaining minus 2 is equals to number of hosts per network, right? So let me just differentiate things for you here and make it simple. So what is network and what is host? So basically network is nothing but it's an identifier, right? It's an identifier for the hosts to communicate within that network only. So I told you that IP address is a subnet related or subnet mask related IP addressing concept, right? It is not classless. So what you can do is, if you create one network IP, right? It will be having few usable hosts. So those few usable hosts will only be able to communicate within the network only, within that network only. So for example, in our scenario, when we calculate later on, I'll explain you what is network and what is host bit using that example only to not confuse you now, right? So I hope this is clear. 2 to the power of network bits borrowed is equals to number of networks. 2 to the power of host bits remaining minus 2 is equals to number of hosts per network, right? Important, right? So make a note of it. Now, now they told us that we have to create 8 subnets from this IP address. How will you do that? What do you know about? I earlier taught you how to convert an IP address, right, a decimal format into the binary. And how do we do that? So for each octet, how many bits do we have? 1, 2, 3, 4, 5, 6, 7, 8. Right? And if we convert these decimals into the binary, how do you do that? You do for each position 0 from right side to left side, 0, 1, 2, 3, 4, 5, 6, 7. Right? So I believe that you might be getting a doubt from the beginning. Why exactly are we using 0, 1, 2, 3, 4, 5, 6, 7 only? Why not something else? Why is it created like this? This is maths, right? So when you want to convert decimals to binary, this is what you'll have to do. And the computer understands binary. It does not understand decimals. It does not understand ASCII values like A, B, A, 1, 2, 3, 4. It doesn't understand that. It has to create everything into binary. So this is what it will do. So now what we do is, if you have to convert the decimals into binaries, you have to 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, so on and so forth until 2 to the power of 7. Right? So what's the value? 1, 2, 4, 8, 16, 32. What is this? 64 and 128. Right? So now when we have the annotation created like this, it's really simple for us to understand how many network bits you can take in order to create 8 subnets. Now from this, where do you see 8? This position, right? So when you see 8 over here, and our job is to find out how many network bits you can borrow from the host bits for creating 8 subnets, we have everything from this particular calculation. So the number one thing is, we see that when 3 bits are borrowed, when 3 bits will be borrowed, that is when you will be having 8 subnets. That is when you will be having 8 network address within whatever we are trying to build from that network. So now let me just clear everything for you. Let's not convert these values into binaries for our understanding. 0 and then 1, 2, 3. So I told you that we have to create 8 subnets. For that, how many bits we have to borrow? We have to borrow 3 bits, right? Is everybody clear? Hello?
Yes.
Guys, I want everybody to unmute and acknowledge. I don't want any questions later on. I still see few people unmute.
Yes, yes.
Yes, yes, yes,
Yes, yes.
yes, yes.
Okay. So these 3 bits we have borrowed, right? So one, two, three, right? We have borrowed 3 bits here, and then the remaining bits we are leaving it. We are just keeping it and will be using it for host addressing, right? So our number one job by the question, according to the question, we need 8 subnets. So to create 8 subnets, we have to borrow 3 bits. And how did we figure this out? We figured it out when we converted the binaries into the decimal. I mean, sorry, I converted the decimals into the binary and found out the value for each position. What's the value for that, right? Accordingly, once I get this, so now I found out that these 3 bits will go here for the calculation part, right? So I told you at the start, I told you creating networks within a network is subnetting. The other definition of the same is borrowing network bits from the host section in order to create a network is subnetting, right? So this is one simple definition. This is something which you will understand the moment you understand subnetting. That's the reason why I have told this particular line here now, after you get to know what we have done here. So is this clear now?
Yeah, clear.
Good. Now,
Yes.
so
Yeah, yeah.
by good. So now by the first formula, we told that the number of networks will be what? 2 to the power of borrowed network bits, right? It is 2 to the power of 3, and we are creating 8 subnets,
Eight.
right? So 8 subnets we are creating, and that is what our question also was. So we have succeeded in our job. That is just the 10% of job what we have done as of now. We have further questions, that is what is the network IP, how many usable hosts are there, and what is the broadcast IP. Now, so now what we will be doing is we will be finding out how many host bits are there, right? So 2 to the power of remaining bits. How many bits are remaining? Team, any guesses?
Five.
Five.
Right,
Five.
right. The reason being this, right? So we see 5 bits remaining, 2 to the power of 5. The formula is 2 to the power of 5 minus 2, which is equals to how much? 2 to the power of 5 is 32, 32 minus 2 is
32
30.
minus 30.
Exactly. So there are 30 usable IPs per network. So that means for each of these 8 network IPs, let's say there is one network, there is two network, there is three, there is four, so on and so forth until 8 networks are there. For each networks, there will be 30 IPs which you can use. You see what we have done, and I believe you will be slowly understanding the concept until now what we have taught, what we have learned, right? So basically, from subnetting, what you have done from a single IP, whatever this IP is 192.168.0.10, from this single IP you have literally created how many hosts for yourself to use? 8 into 30, 240 IPs you have created. So for a very small organization, for an organization of only 200 to 300 members, this is very good number. So internally, in order to route the traffic, you can use this. So you are not utilizing the complete type C network for sending the packets from one host to another host. You are taking one specific subnet and you are creating the networks from that, right? So you're taking this particular IP and creating the subnets from that. And this is what you will be doing when you configure a DHCP server also, right? When you configure a DHCP server, you have to configure an IP and the subnet mask for that. Accordingly, the DHCP will calculate how many IP addresses would be there in that pool, and it will not do any major complex calculation. It will do the same thing what we have done here, right? It will identify, okay, 2 to the power of 8, okay, this is what 8 into 30 is 240, so this is what I have. All those IP addresses per network, it will make a note of it, and according to the request, according to the discover message, it will provide the IP address. Simple. Now, the calculation and the numbering part is fine for us, but what are the actual IP address? How will you write them down? Before we delve into that, there is something called as variable length subnet mask, right? So what does this do? This will help you gather the end network IP. This will help you gather the end network IP, right? Network IP. And also this will help for each network what would be the second network IP address. So for your calculation purposes. So I'll come to the point what it actually does and how we calculate it. So now I told you how many network bits we have borrowed, 3 network bits, right? And since we have borrowed 3 network bits, the from the left hand side 1, 2, 3 are occupied by us for creating the networks. What are the values on the initial 3 side? From the left hand side, 1, 2, 3, right? So when you add this, what's the value you are getting? 192 plus 32, it should be 224, right? There you go. So you have the end IP address here. Now what's the job of this? What is the job of this? It's simple. So let me explain you. So when I showed you the earlier time in our session, I told you that if there is an IP address which you enter in your system, it automatically calculates the subnet mask, right? So how do you convey to the computer that the subnet mask for this IP address is this one, 224, in order to get this particular IP addressing? You create a variable length subnet mask for that IP address, and this is what we just did. So in computer, what you will input is 255.255.255.224. Once you enter this, the computer will now understand, okay, this is the network portion, this is the network portion, this is the network portion. This seems to be the borrowed bits and the remaining host bits, which is amounting to 224. So for this particular IP, it will annotate it as like this, right? That's the use of our variable length subnet mask. Without subnet mask, there is no IP address. IPs will not be able to route internally until and unless you convey to the to your computer or to the system that this is what it belongs to, because it will not understand a slash 27. No, it will not. It will understand this, right? So that's the reason why subnet mask is important. Now, the major important thing. Where did this subnet mask end? 32, right? When you borrowed this network bits, it ends on the this particular position, 2 to the power of 5. So that is what we are calculating for the host bits, right? So in order to create a easy and calculation how you have to actually remember these things, I will give you a very small thing what you can use for calculation. The moment you calculate a subnet mask, that is the variable length subnet mask, the last whatever from the left hand side, last whatever value you see within the conversion, that is what is your next IP for the network. So let me just start now. So in our current example, we needed 8 networks, right? So for 8 networks, the first network is already given to us. which would be, let me just take this, 192.168.10.0. This is the first network IP. This is the first network IP, right? Now, what is the second network IP? 192.168.10.32. Next, second network IP, right? Similarly, so on and so forth. 192.168.10 dot. What would be the next one? It would be the addition of 32. That would be 64. Right now, keep calculating it, and I am telling you this particular value will end after at the eighth subnet, at the eighth network. It will end on this one, and then you will
224.
understand the meaning of this. Right. So let's go step by step. Next, let me just copy this. Why to type it multiple times? Okay. Right. What will be the next one? Ten dot. What's 32 for this 64?
96.
96. Next.
128.
Next.
160. 160.
Next.
192. 92.
Next.
224.
That's it.
Yes.
How many networks we created now? Calculate. 1, 2, 3, 4, 5, 6, 7, 8. What was our question? Create 8 networks. This is what we were asked, right? Create 8 subnets.
Yes.
And we created 8 networks. Right? The first part of your job is done. You created 8 networks. The next question is, what is the next question? So what is the network IP for each network you have given just now? That's done. So 8 networks you created. Good. Now, how many usable IP hosts per network are there? According to your calculation, you have the answer here as 30. Right? What are those usable IP hosts? So they may ask you anything. They can tell you that for this particular network, give me the usable IP host, or for this particular network, give me the usable IP host. Let us take a very simple IP here in order to understand things. So 192.168.10.0 is your network, right? So that's the network IP. What's the first IP then? What comes after 0? 1.
10.1.
Simple. So that's the first IP. Okay. So on and so forth. If you go 2, 3, 4, like this, you will go until 30. Because we have calculated how many usable IPs, 30, right? So 30 usable hosts are there. So this is the end IP, right? But you can see that the next IP is coming from 32. There is a gap here. So after 30, there is no 31. Why? Because for each network, as I earlier told you, for each network, there should be a network IP, there should be a broadcast IP,
This type.
right? So this
We
broadcast
have
IP
to.
is nothing but 31. So for this network, if you have to communicate, so if some organization is using 192.168.10.0/27 as their internal routing address. So this is a department, let's assume. This is some HR department, and they want to broadcast a message. What will they do? They will send a message to 192.168.10.31. Simple. So your machine will send that. Your machine will understand, okay, this is the broadcast IP because as per the calculation, this is what it is. And then this becomes your broadcast IP. Your job is done. So this is what the question was asking you. You have done your job. That's it. Similarly, for 192.168.10.32, What will you do? You will add plus 30. So you will go from 32 to 33, 34, 35, 36 until what value? 62, right? And then you will write 63 as the broadcast and the next IP 64. Done. Understood? Okay. Now, any doubts? Any clarification required? Any calculation related doubts? Anything, right? One more thing, an important thing. If you check your notes, I have earlier told you one important aspect, that is IP rule. And what was that? You can turn your pages or you can turn your documents and let me know that. What was the IP rule that I told you? You've been writing notes, right, guys?
2 bits in the host part in order to create subnets.
2 bits, minimum 2 bits.
In the host part in order to create subnets.
Exactly, that's right. So there should be minimum 2 bits that should be available for you to create subnets. Without that, your subnetting is wrong. So what does that query mean? So that means that, as you see in our example, we have taken 1, 2, 3 network bits towards this side in order to create subnets. But what if there is a question wherein it says that 1, 2, 3, 4, even this are also used to be network in order to create subnets? This is wrong. This is not possible. So an interviewer can give you an example like this. They can tell you that,
Sir,
uh,
once again.
yeah. So what they will do is, see. So I told you that minimum 2 bits are required within the host bits, right? So 1, 2, 3, 1, 2, 3, 4, 5. Right? So in our example, we carried the 3 network bits towards the network portion, and the remaining, how many bits we have remaining for the host section? We have 5 bits remaining for the host part, right? But what does this rule tell is, this rule tells that minimum 2 bits should be remaining within your octet in order to create networks. Otherwise, your subnetting will go wrong. So what happens is, what I'm trying to tell is, if the interview tells you that, let's say you borrowed 2 to the power of 7 network bits from the host part. So how many hosts will you get? The moment you see this 7 here, right, when it's a type C IP address and you see 7 over here, because it's a type C IP address, you know that the initial R network bits are already occupied and only one host bit is there with 8 bits free. Among those 8 host bits also, the interviewer is telling you that we are occupying 7 bits. This is wrong. The reason being, it doesn't follow the IP rule which we are supposed to follow. Now, I am telling you this is wrong. The reason being, if you go ahead and calculate the value, you will not be able to calculate the value. You will get some values which are above 255 and which negates what we are learning here. Why we are concentrating on 255? Because when you convert all these decimal values, the 8 bits of these decimal values into the binary and convert into the value of that particular binary, if you add all those values, it will amount only until 255. If it is above that, it is not going to be understood by your computer, because your computer understands until 255 only, right? That's the reason why this is very important. The number one thing is, you have to understand that minimum 2 bits must be remaining within the host section, right? So you
Last
can,
two.
yes, last show should be remaining for any IP addressing. If it's a class B also, if it's a class A also, that we will learn in the next session, class B and class C, the class A. That's fine. So minimum 2 bits should be remaining. If there are no 2 bits remaining within the host part, you can straight away, when the interviewer is asking the question, you can straight away tell them that this is wrong, this is not going to work, this is what is the rule, right? Now, so I hope this is clear.
Yes,
That's
sir.
important.
Clear.
Yes.
Yeah. Somebody was asking something. Okay. So I hope this particular calculation is done. So what is the network IP? We have these many networks, 8 network. So all the IPs we have listed down here, right? What are the usable hosts among those? The initial IP, the end IP, and the broadcast IP you can calculate like this, right? Initial IP will be the consecutive number, whatever is there, right? 0, 1, right? And the end IP would be whatever the next network you have got, you can just subtract 2 bits from that, two number from that. That is what is your end IP. And -1 is your broadcast IP. So that's how you can learn or maybe remember it. That's how I generally do. You can create your own learning methodology. But this is the basic of it, right? So what are the important things here which we have learned? Number one thing is we have learned subnetting, right, of type C when there is no subnet given and only the required subnets are asked, right? That's the number one thing. Then we have learned what is the network ID, right, or network IP. Don't get confused, it's the same, right? Then what are the host IP within that network, right? That's also we have done. What is the end IP and the broadcast IP, right? What else? We have learned important concept of VLSM, right? What it is, which is nothing but indicating the subnet with a subnet mask. So it's an indicator parameter in order to help understand the computer where should the IPs stop, right? So that's about that questionnaire what I earlier told you, that is subnetting of a type C when there is no subnet and only the required subnets are asked, right? This is what we have learned. Now the next part of the question, this one I will not cover today, right? So what I'll do is I'll give you a few questions which just resolve it. Tomorrow we'll discuss what are the answers, what IPs you have got, what usable hosts you have got, and accordingly we'll move on with the next question type, right? Once you learn type C subnetting, the job is done. Type B and type C, it's just the calculation which is a little bit tricky, but everything remains the same. In type B and type A, or the class A or class B of the IP addressing, the major challenge is this, that in class B we have only 2 network bits and we have 2 host bits remaining. So this 2 host bits amounts to 16 bits. So it actually complexes the calculation part, right? But this can be done, not a problem. Just a minute practice and it is done. Then for class A we only have one network portion remaining completely and all the other are host portion. So you see the complexity here over here. So everything is now reversed. Initially we had 24 network bits in type C, but in type A we only have 8 bits for this, and for the host section we have 24. So you will have many hosts within any subnet of a class A IP. You will have medium number of hosts in the class B, and you will have a reasonable amount of hosts in class C. The class C is a little bit easier to understand. That's the reason why we have started the session with that. Right. So let
Sir,
me.
what is the subnet mask of this which have been done 192.168.10.0? What will be the subnet mask?
What will be the subnet mask is this 192.168.27.
168.10.0 you have been told by 8. 27.
The reason being you are carrying three network bits here, right? And you know that class C IP address is having 24 bits. So subnet masks is only used to indicate to the computer how many network bits are there within the IP. How many network bits did you borrow according to this? How many networks did you borrow? Three, right? So when you borrowed three, your value would be slash 27.
Sir, first you told by 8 na sir.
Which by it?
At first, you scroll up. You have taken 192.168 10.10 by 8 you have taken, I think so. Not 27.
No, 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 no. No, no. Don't get confused with the calculation. We have been asked here for the question 192.168.10.0 create 8 subnets.
8
This is the question.
Okay.
subnets.
They have asked us create 8 subnets. They did not tell that the subnet is 8.
Okay, got it, sir.
Now you have asked me this question, right? You tell me, is this logically valid?
No, that is what I am thinking.
Right. Why isn't it logically valid?
Because by 8 means we will be going to the first 192 octet now, sir, because it will come to class A.
Exactly. Right. So that's the reason why this is wrong.
I thought it after saying 27, I got your answer, sir. I thought it was 8, so that I came again.
Right. No problem. Okay. So that's clear.
Sir,
Now,
most of the cases we will be using subnetting for only private IPs.
no, it's not like that. You will be creating it for public IPs as well.
Okay,
That's the only thing is that is the reason why you have to understand the range of IP addresses, right? So if you know the range of IP addresses, it's easier for you to do subnetting. You can do subnetting for any IP in the world, right? According to the class. If
yes,
they
sir.
give you an IP, let's say 192.170.10.0, which class does this particular IP come under?
Class C.
Right. So what are you going to do? You are going to do the subnetting in the similar fashion, no change. There is nothing which is going to change here. Everything is same,
Okay, got it, sir.
right? So that's how it is. Now, let me give you a few questions so that you can maybe test it out. Okay. Okay. Let's question. Okay. Uh, 192, 168.10.0. Is everybody making a note? Okay.
Yes.
And we need 45 subnets. right? Next, 192.168.10.0, and we need 32 subnets. Not 32, we need 25 subnets, right? So these two questions. So what's the first question? 192.168.10.0, and we require 45 subnets, 45. And the next question is that we need 25 subnets for the same IP. Right? So once we are done, once you maybe practice this today, tomorrow what we'll do is we will try to go ahead with the other way of calculating the network IP, broadcast IP from the given IP and its relevant subnet. So that's way easier than what we have done today. I'll just show you how we do that. Just brush up today on how we are converting the IP address to the binaries. So that will help us tomorrow.